Hi all, my name is Ranjit Karni and today we are going to discuss about cloud computing. So in cloud computing I will be discussing about the topics understanding cloud computing, characteristics of cloud computing service models, cloud computing deployment models, advantages and disadvantages of cloud computing, types of cloud computing, job roles that are available in the market. So before we discuss about the Azure, first let us try to understand about cloud computing, what is meant by a cloud, what is meant by a cloud computing, and then what are the different types of services that are available, what are the different types of deployment models that are available, and what is the basic advantages and disadvantages of cloud computing. So before the cloud computing, what were the things that we were used to do, and then once the cloud computing has come into picture, what are all the things that we are currently doing, and what are the main benefits or the disadvantages that we are going to get by using this cloud computing. And also once you learn this cloud computing, any one of the public cloud or anything like Azure or AWS or Google Cloud, whatever it may be. So when you learn these things, actually down the line, actually what are the different types of jobs that will be available in the market, so that once you learn this subject, so you can go ahead and apply the job for any one of the job roles. So we will see about what kind of trends that are available in the market. Okay, let's start now. So first, the first topic is understanding cloud computing. So first, before discussing about a cloud computing, first let us try to understand about what is meant by a cloud. Okay, so cloud is just a metaphor for the internet. What does that mean? So cloud is nothing but an internet. So we have been having an internet since very long back, right? Like we have been using since our childhood. We have been started using the internet, and nowadays actually each and everything, whether it is a mobile or whether it is a laptop or whatever it may be in the world, actually we have been addicted to the internet. But in the olden days, actually when we were kids or like that, so at that point of time there was no that much level of internet and the bandwidth was pretty slow, right? So cloud is nothing but an internet. I mean to say, like, it is a metaphor for the internet. So when you are talking about cloud, you are just referring to the internet. Nothing, there isn't any much difference between those two things. So we have been having the internet since long back. So and that means cloud is there since long back, right? So what is meant by cloud computing? So you have an internet, okay? Once when you have an internet, storing and accessing the data and programs over the internet. So currently if you have a laptop, you will be storing your data on your system, so which is nothing but is called as a on-premise. Means within your location you are storing your data on your system. Instead of storing the data on your system, instead of storing the program on your system, the same data or the same program, if you are storing over the internet in some certain location, that is nothing but called as a cloud computing. So you are not storing this data on your local machine, you are storing the data somewhere over the internet. Okay, that is called as a cloud computing. So the exact definition is that the practice of using a network of remote servers, the practice of using a network of remote servers hosted on the internet to store, to manage and to process the data, rather than using your local machines or your personal computers. That is what about the exact definition about the cloud computing. It means it is a practice of using a network of remote servers that are hosted on the internet, servers that are hosted on the internet to store the data, to process the data or to manage the data. So whatever you are doing on your local machine, the same thing when the systems are hosted over the internet, and when you are accessing those servers over the internet and storing the data or processing the data or getting the data, retrieving the data over the internet from those servers, then that is called as a cloud computing. In simple words, it is a type of internet-based computing where different services like servers, storage, and applications are delivered to an organization's computers and devices through the internet. Anything that is happening through the internet itself. Okay. So what is the benefit here? See, if you are working on your local machine, let's assume you have stored your data on your local machine, okay, and you are outside of your home, okay, and you want to access certain data, then how can you access your data? Because your data is available on your local machine and your machine is available at your home, but you are outside. You cannot access the data that is available in the at your home. So but whereas if the data is available over the internet on the remote server, okay, wherever you go, anywhere, anytime, any place, wherever you go, you can still access the data provided if you have an internet. The only thing is that you should have an internet. When you have an internet, from anywhere, any place, you can go ahead and get the data at any point of time. So that is what the benefit here it is like. And also it refers to variety of services available over the internet that deliver computing functionality on the service providers infrastructures. So you no need to bother about the infrastructure as well. So the service, whomever is providing, the provider, whomever is providing the service, he will be taking care of those servers and all those things. You just go ahead and utilize those services by making a payment, like whatever the services that you are using. Based on those services, you just go ahead and make those payments and then start accessing those things. I will be going in depth about those list of services and all those things down the line, but currently understand that the provider will be providing the infrastructure to you, and whatever the service that you require out of those infrastructure, you will be utilizing that service and you will be making the payment only up to that service, that whatever you are utilizing. So the next point is it avoids or minimizes. So what is the benefit here? As you will be utilizing the service till the time that you are required. When it is not required, you will just say that okay, this service is not required for me. So like that, what you are doing here, you are protecting your data, you are minimizing your licensing costs, you are removing hurdles like frequent upgrade to latest technologies, maintenance and upgradation of software or hardware. Why? Because you are not maintaining the infrastructure, so you no need to bother about the latest technology upgrades or the maintenance or the upgradation of your hardware, because you are not procuring the hardware. Hardware is procured by your provider. You are just utilizing the service. So the service, whatever the service that you need, you will be requesting to the provider, and provider will be providing those things, and then you will be utilizing those things. So these are the couple of better examples which we will be explaining further. Okay, so cloud computing is nothing but cloud is nothing but an internet, and cloud computing means over the internet, whatever the servers that are hosted over the internet, when you are accessing those servers over the internet and storing the data or processing the data over the internet, that is nothing but as a cloud computing. Why recently the cloud computing has been come, and earlier why it was not there? In the sense, see, earlier also cloud computing was there, but the problem here is like in the olden days the bandwidth of the internet was pretty slow. So as the cloud computing is completely depending on the internet, the problem here is that when the internet is not fast, then cloud computing will never going to work out, because the entire data will be available over the internet and you have to access the data. So that is the problem that will be going to arise. So that's the reason, as currently nowadays the internet speed is pretty fast, so people started migrating from on-premise to cloud computing. Why? Because the internet speed is good, so that they can access the data pretty faster as well. So that is the main benefit. Okay, now let's try to understand what are all the characteristics of cloud when it is compared with the traditional hosting with the on-premise instances. So when you are comparing the cloud with those things, so what are the characteristics that you are going to get here? So what are the characteristics? See here. So one is remotely hosted. Remotely hosted means whatever the services or data that are hosted on remote infrastructure. So you are not hosting your things on your local on premises. You are not procuring your thing. The infrastructure and everything are hosted on the remote location. So you no need to bother about the infrastructure at your on premise. So one thing is the benefit over here. The second thing is ubiquitous. The services or the data are available from anywhere through internet. So the benefit, this is the main benefit actually. So you store some data on the remote server over the internet, and wherever you go, provided if there is an internet facility that is available, then you can just connect to that server over the internet and then you can grab the data. And also the resiliency is nothing but cloud providers generally mirrors solution to multiple data centers to minimize downtime in the event of disaster. That means, see, whomever may be the provider, whether it is Azure or AWS or Google Cloud or any public provider, that any provider that may be, when you are utilizing some service, for that particular service, when you have requested for one data center location, then automatically the provider's responsibility is to provide you at least 99.99% availability. It means if you are asking about one data center, in one data center, automatically he will be storing the data in 3 locations by default. But he will be charging only for one data center, but he will be storing the data in 3 locations. So if one data center is going down, automatically he will be making the other data center one as up, so that your application will not go down and still it will be maintaining the 99.99% as promised by your provider. So it automatically mirrors is nothing but replication. It replicates the data in multiple data centers to minimize the downtime in the event of disaster. Whenever there is something happens to your main server, then automatically the other mirrors that are available, that are created by your provider, he will automatically make the one as up, so that your application will not be facing any kind of issues. On demand self-service means a consumer can himself provision computer capabilities such as server, time and network storage as needed automatically without requiring human intervention with each services providers. It is sold on demand mostly by the minutes or hours, pay as you go model. See, earlier in the olden days, when you are not maintaining your on-premise infrastructure, and then when you are depending on some data centers or something like that, whenever you need to have some extra space or something like that, first you need to send an email to the data center guys and then ask them whether there is any space available, and they have to reply back like whether the space is available or not. Based on that one, you will be asking, okay, I need one more virtual machine, or I need one more physical machine where I should be storing some data. So these kind of communications used to happen between the data center guys and our company folks, and then based on the data size, availability and all those things, we used to store the data. So there is a kind of human intervention used to be there, and blindly we cannot go ahead and take the space from the data center. But if you are on the cloud and if you want to spin up an extra mission or extra space, you don't need to contact anyone. Just go ahead and with couple of clicks or couple of automation steps that you have already incorporated, whenever it is required for you based on the demand, maybe when the spike is going up, when your application traffic is more, then at that point of time you can go ahead and spin up one more instance and then attach that to your load balancer and start utilizing that one. And whenever the traffic is low, whenever your application utilization is less, then at that point of time, if a extra mission is not required, you can just put down the server and then utilize how much ever may be the space, or how much ever may be maybe the server number of servers that are required. So there is no kind of manual intervention, and just it is on demand self-service. With couple of clicks you can go ahead and do your action. So the benefit here is like whatever the utilization that you are doing, only up to that level of number of hours, or up to that level of missions, or up to the level of that space, that whatever you are utilizing, you will be making the payment for that one only. And whenever the system has been turned off, then at that point of time you no need to make the payment for that particular thing. So this is what as pay as you go model, you will be making the payment only for the number of minutes or number of hours that you are utilizing it. And rapid elasticity, a user can utilize as much or little of the cloud service as required. For example, resources like web servers on the cloud can be scaled to meet a high traffic in peak times, or scaled down in times of less traffic, as I said. So based on the traffic, basically if the traffic is more, then you can go ahead and spin up a new instance, and then you can start utilizing that one. When the traffic is less, then at that point of time you can bring down the server, you can scale down the server actually. So that is what about the rapid elasticity. Broad network access capabilities are available over the internet, over the network, and accessed through standard mechanisms that promote use of heterogeneous thin or thick client platforms, mobile phones. So from wherever you want to access the data, actually, if the data is available on the cloud, then from your mobile phone or on your laptops or on your PDS, whatever it may be, you can go ahead and start accessing the data by connecting to the cloud actually. So fully managed by the provider. The user is abstracted from the details of how the service is managed in the cloud. For example, the user need not worry about aspects of such as hardware used, software updates, patches, plugins, web services, web security. There is optimum utilization of resources as well as sharing of resources, everything taken care by the provider. As I said in the beginning itself, when I was talking about the cloud computing, the maintenance of your infrastructure, the patches, the installations, the upgradations of the hardware, the plugins, the web security, all these things you no need to worry about all these things. The provider from whom you are trying to get the services, that provider's responsibility to maintain all these things. So you no need to deploy new resources, new team members who has to maintain your infrastructure and all those things. No need to worry about all those things. All those things will be maintained by the provider himself. So the characteristics here are: one is the remotely hosted, next ubiquitous, and then the resiliency, on-demand self-service, rapid elasticity, broad network access, fully managed by the provider. So these are all the different characteristics of cloud when you are comparing with the traditional hosting. Cloud computing service models. So in cloud computing, I was telling like you can utilize the services actually, but what are all the different types of service models that are available? First of all, okay, there are three types of service models that are available. One is IaaS, means infrastructure as a service. Next, platform as a service. Next is software as a service. So let's see actually what is the difference between infrastructure as a service, platform as a service, and software as a service. So infrastructure as a service. So infrastructure as a service, in the sense it delivers the computer infrastructure, typically a platform virtualization environment, as a service. So let me go to the diagram first so that it will be very clear for you. Okay, so if you see on-premise instances, when you are talking about on-premise instances, you have to procure your hardware. Okay, you have to set up your networking, you have to set up your storage part, servers, you have to do the virtualization, and then you have to install the operating systems, you have to maintain your middleware, you have to maintain your runtime, you have to maintain your data, and then you have to maintain your applications. So you have to develop your applications and deploy your applications. So from procuring your hardware, networking configuration till the application development and deployment, entire responsibility is yours. You will be managing from end to end on your on-premise environment. Whereas when it comes to the cloud, there are different sections, there are different types of service models, as I was saying: infrastructure as a service, platform as a service, and software as a service. So when you are talking as infrastructure as a service, what are all the things that you are supposed to be performed? Let's see here. So you no need to bother about the networking configuration, the servers, the virtualization, and the operating systems. So the only thing is that with couple of clicks you will be selecting what operating system you would like to deploy. Okay, and then what is the size that you would like to have for that particular virtual mission, and then you will be on then immediately the virtual mission will be get created with that particular OS available on that virtual mission, and then you will be maintaining. Your responsibility is to maintain the middleware, to maintain the runtime, and to maintain the data and the application. So it's your responsibility to maintain. If suppose it's a .NET application, let's assume, okay, it's your responsibility to install the .NET framework on your mission. It's your responsibility to install the web server like IIS or anything. It's your responsibility to install. It's your responsibility to install the data like database or anything, and it's your responsibility to perform the deployment on the application. So the middleware, the runtime, the data, and the applications, that itself has to be maintained by you. The remaining, the network, the patches, the upgradations, and everything will be taken care by the provider. So that is what infrastructure as a service. If you see here, it delivers the computer infrastructure. So the provider will be delivering the computer infrastructure, typically a platform virtualization environment as a service. So they will be providing in the form of a virtualized missions to you with the OS installed on the virtual mission. So it's on top of that one, it's your responsibility to maintain the runtime of settings, and then the middleware configuration, and then the data and the development and the deployment of the application has to be done by you. The cloud providers build the data centers. They will be building the data centers, they will be managing the power, they will be scaling the hardware, networking configuration will be done by them only, storages, distributed systems, everything will be taken care by the cloud. Rather than purchasing the, so what you are, if you are on premise, you have to purchase your servers, you have to purchase the software licenses, you have to purchase the data center space or network equipment. Clients instead buy those resources as a fully outsourced service. Yeah, few people will be doing that one. So what you are doing here, instead of doing all these things, you will be just are getting a service from the provider, and provider will be taking care of all these things, purchasing the servers, I mean to say, like he will be building the data centers, he will be maintaining the power, hardware, networking, storages, and everything will be maintained by the provider only. So what are the different types of providers we have, like Amazon Web Services or Azure or Google Cloud or Alibaba, whomever, or IBM, so whomever it may be. So you will be going ahead and utilizing those services from those providers, and it's providers' responsibility to maintain all these things. Whereas a platform as a service, let's see. So in the platform as a service, still you no need to worry about the runtime configuration, you no need to worry about the middleware as well. So just the only thing is that you develop your application and then come and deploy your application. Just develop and deploy your application. You no need to worry about the runtime and middleware as well. Even those things, the creation of virtual mission, the installation of the runtime things, the installation of the middleware, the configuration of those things, everything will be taken care by the provider. So it's your responsibility is just concentrate on the development of your application, and once the development is completed, just go ahead and deploy that application on the servers, that whatever the things that are provided by the provider. So just go ahead and deploy the application and start utilizing that application. So the benefit here is like you will be having more time to concentrate on the application development and deployment, rather than concentrating on the operating system, runtime and middleware and all those things. So this is what the benefit with the platform as a service. So if you see here, it provides, the provider will provide developers necessary tools to create, test, host and maintain the created application. So it provides an environment for you to create an application, or to test an application, to host an application, to maintain an application. So it will be providing an environment for you. The only thing is that you come here, develop your application, host your application and start testing your application. That's all. Cloud providers offer an internet-based platform to develop who create services but don't want to build their own cloud. So the same examples only here also. So but last thing is that software as a service. So here in the infrastructure as a service, you are maintaining the runtime, you are maintaining a middleware, you are developing your application, you are deploying your application. Whereas in the platform as a service, you are not maintaining the runtime, you are not maintaining the middleware, you are not bothering about the operating system, virtual machines or the networking or anything. You are just concentrating on application development and deploying the application and start testing the application. But whereas in the software as a service, you still no need to worry about the application as well, development as well. The application deployment will be already done. You start utilizing that application which has been deployed as a part of end user. As a end user, you can go ahead and start utilizing that application as a service. The examples here is like, if suppose you want to use the Gmail is an application which has been deployed already on the servers. So you will be accessing that as a form of an end user, you will be utilizing that service, right? SaaS, software as a service, is a software that software delivery methodology that provides licensed multi-tenant access to software, and it functions remotely as a web-based service. You try to understand. So nowadays, actually, most of the people, earlier there were a lot of desktop based applications, but nowadays people started creating web based applications, so that by creating the user ID and password, so that from wherever you want to access the data, you can just access the data, and your data will be pretty much secured, and based on the internet speed, your application will be pretty faster as well. So from end users point of view, apps are located in the cloud. See, apps are located in the cloud, and it's almost always accessible through the web browser. So it is not a desktop application, it is a web application kind of stuff. So whenever you want to use it, you just go to that URL and then start utilizing that features. Any application posted on the remote server can be accessed over the internet is considered as SaaS. Usually building based on usage and multi-tenant environment. So what it is actually, any application that is hosted on the internet, and then if you are starting using that one, then you are not developing anything, right? You are just utilizing that application over the internet which is hosted on the remote server. So that is called as a software as a service. So I hope that you understood. So infrastructure as a service means you are maintaining a middleware, runtime, data and applications. Platform as a service, in a sense, you no need to worry about anything. You just concentrate on your application development and then deploy the application and then test the application. And whereas software as a service, in a sense, you no need to worry about even the development and deployment and testing the application. You just start utilizing that application as an end user. That's all about the infrastructure as a service, platform as a service and software as a service. So these are the different types of service models that are available in the cloud computing. Next, cloud computing deployment models. So what are all the different types of deployment models that we have here? So one is private, next public, and hybrid. So what is meant by a public cloud, public cloud, or a private cloud, or a hybrid cloud? Let's see here. A private cloud is a hosting solution which is also known as an internal cloud or an enterprise cloud, resides on company's intranet or hosted data center where all of your data is protected behind a firewall. See, there are most of the companies like Walmart or some XYZ companies, they have bought huge number of servers already. They have invested huge amount on the servers already, okay, and you have started saying now like we have started saying now like actually instead of hosting the applications, instead of setting up a data center on your on-premise location, why can't you start using a remote servers that are provided by some other XYZ provider? When you are doing that by utilizing the services from the XYZ provider, what about the servers that you have already procured, that you have already invested? So what few companies like Walmart and other companies are doing is they have already invested huge amount on the data centers, huge amount on the infrastructure already. So instead of just wasting that amount and then throwing those servers and then start using the providers, they themselves internally has created a data center, a hosted data center, which is nothing but called as a private cloud. So which will be utilized by that company itself, only for that company itself. The data center will be utilized by that only company because they already have the huge infrastructure and they would like to utilize that one. So which is nothing but called as a private cloud hosting solution which resides on company's intranet. So in the company's location itself it will be available, or a hosted data center where all your data is protected behind a firewall. This can be great option for companies. See here, this can be a great option for companies who already have expensive data centers because they can use their current infrastructure. They already have huge infrastructure that is available. Instead of going over and then start using the other providers services by spending extra amount, you know, whatever the services that you already have, start utilizing those services, and in future you can go ahead and start using the public cloud. Okay, for the time being you can start utilizing your own services from your own infrastructure itself, from your own company's intranet itself. So that is called as a private cloud. You go for a private cloud when you have strict security and data privacy issues. So for example, there could be couple of places where your government data or something might be available. You are handling the government data or something, and the government has a restriction where they do not want the government data to be kept on the public cloud. So at that point of time, it's your responsibility to maintain the data within your company's intranet itself. So that there could be couple of policies where due to some restrictions, you know, due to some privacy, data privacy or the security reasons, you have to maintain the private cloud where you have to maintain your own hosted data center or a company's internet location, and then you have to maintain these things. So the benefit or this is about the private cloud. But the drawback here is that the main drawback is you see with the private cloud is that the management, the maintenance and the updating of the data centers is your company's responsibility. If you are thinking about the public cloud, when I was talking about the different service models, networking, the upgradations, the maintenance, nothing has to be taken care by you. Everything will be taken care by the provider. But as you are maintaining your own servers by yourself within your company intranet, within your hosted data centers, then it's your responsibility to maintain the upgradations, patches, maintenance, or the upgradation of the hardware, whatever it may be. All those things has to be maintained by your company only. It's your responsibility. That is what the drawback that comes up with the private cloud. Whereas a public cloud in the sense, whatever the things, these are the clouds which are open. These are the clouds which are open for use by general public. Anyone whomever wants to access this one, just go ahead and access that one, and they exist beyond the firewall of an organization, fully hosted and managed by the vendors. Your data is stored in a provider's data center. The data will not be stored in your local machine or in your hosted data center. The data will be stored in the provider's data center, and the provider's responsibility is to manage and maintain of the data center. So here the benefit here is that when you are maintaining your data in the provider's data center, then the maintenance and the management of your data, of the data center, is not your responsibility. You are just utilizing the service and making the payment for that service. The maintenance and the management of the data center has to be done by the provider. You can share the computing resources among the network of users. The public cloud offers greater flexibility and cost saving. Let's assume you have a servers on the data centers, and then you may be requiring some space or a small virtual machine within that server. At that point of time, why do you need to buy the entire data center location of the server or something like that? You can just share that resources with any other people. Instead of a dedicated one, you can go ahead and share it, so that the cost of that utilization, the cost will be less, and it will be very flexible as well, so that you will be paying very less amount that for the services that whatever you are using. You can purchase the capacity on the basis of uses and scale up or scale down server capabilities based on the traffic and other dynamic requirements. Means as I was saying, whatever the services that you are utilizing, pay only for that utilizing, until whatever may be the amount that you are utilizing, pay only till that amount itself. So pay only till that time itself, so that you know what is happening here. Whatever the utilization that you are doing, you are making a payment, only pay till that utilization level itself. So but the drawback here is that they are more vulnerable than private clouds, and there is no control of resources used or who shares them. So you have not put it as a dedicated one, and you have put it as a shared one. You are fine to use it as shared services, but you cannot control and say to the provider like, okay guys, okay, I am fine with the sharing, but you have to share it only with so and so company, with so and so people. You will not be having such kind of control. It should be a open. It's a very flexible one. Whomever wants to use it, it randomly assigns that thing to that one. So you will be shared with some XYZ person whom you will not be knowing, like with whom you have shared, and it's the responsibility of provider, and it's the responsibility of provider for the security and data privacy and all those things has to be maintained by the provider only. Note here is, even though you don't control the security, that's what I was saying, right? Even though you don't control the security of private cloud, all your data remains separate from others, and security breaches of public cloud are extremely rare. See, let's take an example of Microsoft itself. Microsoft entire data is available in the Azure, right? So when their data is available in the public cloud, if the data privacy and all those things, if they are not maintaining in a proper way, obviously data might have been already got stolen by this time, right? So you no need to worry. Even though you are sharing your resources with others, still there will be a proper security, still there will be a proper data privacy that will be available with the public cloud. So they will be maintaining very strict policies, OS rules and all those things will be implemented over here, so that there won't be any kind of security vulnerabilities and all those things will be arising over here, and everything will be maintained in a proper way. So that is about the public and private cloud. Let's see about the hybrid cloud. So hybrid cloud is nothing but they consist of external and internal providers, namely a mix of public and private clouds. Secure, so what it is, you see here, you have a secure hybrid cloud, you have a private cloud over here, you have a public cloud over here. When you want to have a connection between your on-premise and to the cloud, there should be a kind of bridge that has to be set up between your on-premise data center and the cloud. So that is nothing but called as a hybrid cloud. So here you can use express routing, one of the best thing that Azure is providing. So Azure is best suited for hybrid cloud basically. So in order to set the bridge between the on-premise and your cloud services, then that is nothing but called as a hybrid cloud, and you can maintain a security for the hybrid cloud as well. So secure and critical apps. See, basically what people will be doing is like they will be hosting their application on the cloud, but they do not want to host their database on the cloud because there could be some kind of security reasons that will be available, right? So what it is, so your cloud services has to be, your application has to be speaking with the on-premise one. So there should be a connection that has to be set up between your on-premise data center, because the database is available over there, and your cloud, because the application is available on the cloud. So that kind of bridge will be created by the hybrid cloud. So if you see here, secure and critical applications are managed by an organization, and not so critical and secure apps by a third-party vendor. For example, you can use a public cloud to interact with the clients, but keep their data secured in a private cloud. Most companies are not switching to the hybrid clouds. Ideal in situations where you have plans to migrate. So when you are going to use half here or half here, in the sense you want to migrate. So nowadays people started, even the Walmart also started migrating their applications slowly from on-premise to cloud. Then what it is, instead of moving the entire applications at one shot from your on-premise to cloud, slowly you can migrate your applications one by one from on-premise to cloud. At that point of time, as there might be different dependency between the applications, you will be setting up a bridge between the on-premise and the cloud, a public cloud, so that actually there will be a kind of communication that will be happening between these two things. So this is about the hybrid cloud. So the private cloud is something that where you will be maintaining your own things, the maintenance of the application, the maintenance of the hardware, the patches, the upgradations, and everything will be maintained by you. The benefit here is like whatever the resources that you already have, those resources you can start utilizing those things on your hosted data center or on within your company's intranet itself. Whereas the public cloud, in the sense, everything will be maintained by the provider. Your only thing is that you can start utilizing those things and pay for whatever the services that you are going to use. Hybrid cloud is something that half of your data might be hosted on your on-premise, and the applications that are few applications might be hosted on the public cloud. In order to have a connection, the bridge between the on-premise and the cloud is called as a hybrid cloud, which is something like a express routing, and Azure is the perfect suitable for this kind of hybrid cloud examples. So what are the benefits? Let's see what are the benefits that you are going to achieve with the cloud. So you have seen, you have understood about cloud computing, you have seen the characteristics of cloud computing, we have discussed about the different types of service models that are available, like infrastructure as a service, platform as a service, and software as a service. And also we have discussed about the different types of deployment models like private cloud, public cloud, and hybrid cloud. So these are the different types of lists that we have already discussed. So by this time you should have been understanding like what might be the advantages and disadvantages of cloud computing. Basically there are a lot of advantages with respect to the cloud computing, but there could be a slight disadvantages as well, but which we may not be considering much as seriously. But still, I would like to discuss, like there could be a couple of disadvantages also there. So first, let us concentrate on the advantages of cloud computing. So the first thing is that lower computer cost. You no need to buy a suppose you want to use your server, number of servers, when the traffic is more, you may be requiring 100 servers. Let's take a simple example, 100 servers, and when the traffic is low, you may be maintaining a 70 servers itself. So you no need to buy, for the sake of that 1 or 2 hours or 1 or 2 days of time, when the traffic is more, you don't need to buy the servers and keep it at your on-premise, even though they are not utilized. So whenever you utilize it, you will be utilizing it on the cloud, and then whenever it is not required, you will be turning off, and then you will not be utilizing. But when you are not using the cloud computing, and when it is a hosted data center, but still you have to maintain all those 100 servers, whether you use it or not use it, because you already spent amount on those things. So with the help of cloud computing, you are lowering your computer cost, because whatever you use for that particular level of time itself, you will be making the payment, and when you do not require, just turn it off and no need to make the payment for those things. Next is improved performance. So improved performance in sense, when you are, that's what I am saying, right? So everything is interrelated actually. So improved performance in the sense, you will be always, the software will be, the hardware and the maintenance will be perfect, and the hardware will be always upgraded, so that the better performance will be available over here. And whenever the performance is going down, you can immediately spin up an instance and then scale up, and then you can maintain your application with the proper performance levels. Reduced software cost and instant software updates. So the software updates and all those things will be maintained by the provider. So it's his responsibility to ensure that all the latest updates are available on the mission, and the upgrades, the proper updates are happening on the hardware side and all those things. And also the software cost, if you have your own license, then you bring your own license concept is also there, so you can get your own license and start utilizing that one, or you can buy the license if you do not have the license available. Unlimited storage capacity. So the storage is, see, you have ample storage that is available. If you want it, you go ahead and utilize it, and if you do not want it, no need to use it. But the good thing here is that whatever you utilize, pay only for that utilization. It doesn't matter how much is the space that is available. It doesn't matter. You have ample space that is available, but you can use ample space, or you can use whatever the extent of space that is required for you. You can use up to that space itself, and you can pay only for the usage of that space, not for the entire space that is available on the cloud. So that is the beauty here. Universal document access, increased data reliability, and device independence. So these are the different types of advantages of cloud computing that are available. Let's see the disadvantages. So the disadvantages here is it requires constant internet connection. This is the main thing, as I said. See, the main thing that you should be having to do a cloud computing is you should have a proper internet connectivity. If you do not have a internet connectivity, if your bandwidth is slow, then definitely cloud computing is something not which you should be choosing of. So you should not be choosing that one. When you have a proper internet connection, then only the cloud computing is going to work. So this is one of the disadvantages, I would say. If you have not, if you in few locations, in few remote locations, still there will be areas where there could not be a proper internet connection. If the internet connection is not there, then definitely you cannot connect to the cloud actually. Do not work well with low speed connections, as I said already, internet issues. Features might be limited based on the provider you choose. So few providers like Azure might be having few services that may not be there in AWS, or that may not be there in the Google Cloud. So when you are choosing a provider, just ensure that what are all the services that you are supposed to use, and whether those are services are provided by the particular provider or not. Can be slow, obviously. When the internet is having a problem, it can be a slow. Stored data might not be secure. See, 100% it is secured, but still there will be few companies where they will be having like, oh, my data is not stored by me in my location, and it is stored on some cloud. So there could be a kind of security breaches. So people will be thinking, but no, there won't be any kind of breaches, because actually the provider will be making sure that the data protection is always there, maintaining a proper data privacy, and the security will be done by the provider. But still I kept it as a disadvantage. But mostly people are assuming that, but there is no kind of data security breach or anything actually. So everything will be maintained properly by the provider. So these are about the advantages and disadvantages of cloud computing. Mostly advantages only, disadvantages are very less. When there is an internet issue only, there could be some problem. Otherwise there won't be any kind of issues that will be arising with the cloud computing usage. Next, types of cloud computing job roles. So once you learn the cloud computing, once you learn any type of any public provider, like AWS services or Azure services or Google Cloud services, what are the jobs that you will be going to get? So one is cloud system engineer or application developers. So developers, whomever is like .NET framework, .NET guys actually. .NET guys now, instead of developing their applications, they have to use couple of services that are available on the cloud as a software as a service, or they want to store their data on the storages, or they want to deploy their application on the IaaS, infrastructure as a service, that is the virtual machines, or they want to use the platform as a service methodology on the cloud. So they should be knowing the cloud knowledge. So application developers, if they are learning a cloud, then they will be suitable for application developers with cloud knowledge. DevOps engineers. So DevOps engineers' responsibility is to do the automation of their infrastructure, whether it is on-premise or cloud. So they should be having a knowledge on the cloud as well. So you can become a DevOps engineer. Cloud architect. If you are expertise on the cloud, then you can become a cloud architect. Cloud service developer and cloud system administrator. See, even Azure will be Azure or AWS or whatever will be the provider. If you are not maintaining the infrastructure maintenance, then definitely the provider has to maintain it. So provider has to have the resources available in his company to maintain those infrastructure, right? So you can work directly with the provider, and then providers in the provider company, and then start maintaining those servers of the cloud, like as a cloud service developer or the cloud system administrator or cloud sales executive. If you have a good communication skills, and if you have a knowledge on the cloud, you can go ahead and discuss with the clients, and then tell them like what kind of cloud services that they can use for their requirements. And as a cloud consultant or as a site reliability engineer, see, there is a huge demand in the market currently for cloud computing, and these are the list of jobs that are available in the market, where you can go ahead and based on your requirement, based on your experience, or based on your previous knowledge, and based on the knowledge level that you have gained with the cloud computing, you can choose any one of the job roles. Okay, let me go to. Okay, so till now we have discussed about the cloud computing. We have discussed about the characteristics of cloud computing. We have discussed about service models that are available in the cloud computing, and then we have discussed about deployment models in the cloud computing, and then the advantages and disadvantages of the cloud computing, and also we have discussed about the cloud trends, what are the different types of jobs that you will be going to get once you are done with the cloud computing training, or once you are done with the learning of cloud computing. Now let's see actually what are all the principles of parallel and distributed computing, and also let us see the architecture of cloud computing, and then what are all the providers that are available in the cloud right now. Let's see. So parallel computing, what is meant by a parallel computing? A system is said to be a parallel system in which, if you see the diagram here, by seeing this diagram itself you will be able to understand. A system is said to be a parallel system in which multiple processors have a direct access to a shared memory which form a common address space. See here, you have one CPU, 2, 3, 4. 4 CPUs are available, whereas 4 CPUs are connected to a shared memory and form a common address space. So this is nothing but a parallel computing. You can see here all the CPUs are tightly coupled because they have shared a common memory. So that's the reason all CPUs are tightly coupled system, and it is designed to speed up the execution of a program. Why it is speed up for the execution of a program? In the sense, it is simultaneous use of multiple computer resources to solve the computer problem. So whenever a problem that has been assigned, then it run the problem using multiple CPUs, and a problem is broken into multiple discrete parts that can be solved concurrently. A problem can be solved concurrently by breaking that problem into discrete parts, and each part is further again broken down into the series of instructions, and instructions from each part execute simultaneously on different CPUs. So that is the reason, as a problem is split into multiple parts, and as those have been processed concurrently by using the multiple CPUs, that is the reason actually we would say that the execution of the program speed is more. So this parallel computing is useful whenever you would like to do some scientific calculations or something, then this parallel computing will be useful for you, and those are the tightly coupled ones because those are sharing the common shared memory. So what type of applications that are available in the parallel computing? The parallel computing would be two servers that share the workload of, it would be two servers, at least minimum two servers that will be sharing the workload of routing mail or the solving the mathematical problem. And supercomputers are usually so what kind of computers? Basically any supercomputers that will be normally placed in the parallel system architecture. Terminals are connected to a single server. So what are the advantages here? So the advantages is here the cost saving and time saving, because you are cutting down the problem into multiple things so that your time is getting reduced, and as you are maintaining a shared common memory, so the cost is also saving. Overcome memory constraints, do multiple things at the same time. Disadvantages is lack of scalability between memory and CPU. It's programmer's responsibility for the correct access of global memory. So they should be utilizing the memory in a proper way. So it's programmer, whenever they are writing a program, so they have to ensure that no memory is getting wasted, and whatever the thing that they are supposed to use, the correct access of global memory has to be utilized. The programmer's responsibility for that part. Whereas distributed computing is nothing but a collection of independent computers interconnected via network capable of collaborating on a task. See, It is loosely coupled system because each process has its own memory and various communication lines will be available. Each CPU will be having its own memory, and so that what it is happening, it is a loosely coupled system, and each processor will be having its own memory. It maintains a client server architecture, and the examples here is telephone network, cellular network, ATM machines, computer networks such as internet and mobile computing. So these are all the different types of client server architecture ones that are using the distributed computing methodology. So the distributed computing server is classified as two types basically. Either it is as a computer server where client will be sending a request, and then the server will be responding back with to the client. That is the client server architecture. And the file server is that it provides a file system interface where client will create or update or read or delete the files that are present on the server. Server will be having all the files, or where the client will be accessing those files or creating the files over the server, or he will be performing some kind of updates or deleting the files that are present on the server. So the advantages here is like resources sharing, computation speed up. The main benefit here is the reliability and shorter response time, as it is maintaining client server architecture. The response time and all those things, the performance wise it will be better because it's maintained. So each CPU will be having its own memory, so it can be used only for the particular CPU only, and there will be an interconnection relation, communications will be happening as a part of network part. So what are the differences between the parallel and distributed computing? Let's see. Memory size. It is tightly coupled. Memory is tightly coupled. Why? Because the memory is shared across the CPUs in the parallel system. In the distributed side, it is a loosely coupled because each and every CPU that is available, each CPU will be having its own memory. That's the reason it is loosely coupled. Control. All CPUs will share the global clock control. So there will be, each CPU will not be having its own timestamp. All CPUs will be having a single timestamp. A global clock control will be available. Whereas in distributed, each system is independent to another, so there is no global clock control. So each CPU can be having a different time zones, time clocks that are available. Processor. In parallel, processor interconnection is in the order of, see here, the speed. The processor interconnection is in the order of terabytes per second, whereas in distributed, the processor interconnection is in the order of gigabytes per second. The main focus here is that in parallel, the main focus is on performance of the system and scientific computing, whereas the distributed is also main focus is on performance itself. It's based on the cost and scalability, reliability and resource sharing. So ultimately, if you want to have a multiple CPUs with a shared memory in the form of a tightly coupling one, then go ahead with the parallel system. If you want to have it loosely coupled with each CPU having its own memory, and then with a different global clocks there at the point of time, go ahead with the distributed ones. So based on your requirement, you can choose any one of those different types of computes. So the cloud computing architecture. So you see here in the cloud computing architecture, this is your infrastructure and this is the provider's infrastructure. So over the internet, you are connecting from your location to the provider, and you can see here the provider has his own infrastructure and his own storage and the runtime cloud that is available and the list of services that are available and the application that you have deployed. Okay, so from the infrastructure till the application level, that whatever you have deployed, the management will be done by the provider only and the security will be maintained by the provider only. So the entire infrastructure, storage, these two things will be maintained by provider, the runtime cloud and the services. Whatever the services that you would like to use, you can go ahead and utilize those things, and the application will be developed by, so based on the platform or infrastructure service or the software service, the application will be maintained by either by the client or by the provider based on the types of service that you are utilizing. But the entire management of the hardware, the patches and everything will be maintained by provider here, and the entire security will be maintained by the provider only. So this is about the graphical view of cloud computing architecture. So you can see here, users may access the internet from any type of their gadgets, right? That you know already. So cloud computing comprises of many components, such as each of them are loosely coupled. So this one you should be understanding. So if you want to use storage, you can go ahead and use the storage. You don't need to worry about the databases and all those things. In a similar way, if you want to use the database, then you don't need to worry about the virtual machine. You can just go ahead and use the databases. So each and every service that is available in the cloud, everything is loosely coupled. There is no dependency between the services, so that if you use this service, then you have to use some other service like that. There is no dependency. Each and every service is a independent one. So cloud computing is broadly divided into two parts. That is, the front end refers to the client part of the cloud computing system. It consists of interfaces and applications that are required to access the cloud platform web browser. It comprises of virtual machines, storages, security mechanisms, services, deployment models and servers, etc. So you can see here, so these things, primary and so the back end and front end and the back end ones. So based on your requirement, you can go ahead and utilize any services, that whatever the services that you want, and you can make the payment only for that particular services alone. So this is about the cloud computing architecture. Let's see what are all the major cloud infrastructure providers that are available. You see here in this diagram, extreme right hand side, on the top side actually, you can see the leaders. Who are all the leaders that are available currently? Amazon Web Services and Microsoft. So this is taken in June 2016. So now even Google Cloud has been moved as a leader, and even IBM is in the good shape now. Alibaba is also in good shape. Oracle is also in good shape. You know, Amazon Web Services, Microsoft and Google, all these are in the leader side, in the visionary side, and IBM, Alibaba, Rackspace, Google Cloud, AT&T, they are becoming as a challengers, where down the line they may also become the leaders. So these are all the different cloud infrastructure major players that are available in the market. So this is about the cloud computing. And so till now what we have discussed is what is meant by a cloud computing, what are the different types of service characteristics of cloud computing, what are the different types of service models that are available, like infrastructure as a service, platform as a service, software as a service, and also we have discussed about the deployment models, that is public, private and hybrid cloud, and we have discussed about what are all the advantages and disadvantages of cloud computing, and we have discussed about what are all the different types of jobs that will be available in the market once you learn the cloud computing, and we discussed about the parallel computing and the distributed computing, what is and also we have discussed about the cloud computing architecture, high level architecture diagram, and we have also seen what are all the major players that are available on cloud infrastructure. So this is about the cloud computing. So later part we can discuss about the Azure, the basics of Azure, and then later we'll be digging more into the each and every service and then seeing the options of those services.